morning students. Today IIT-JEE NEET Foundation. The topic is electricity, electrical circuits. So electric circuits are nothing but they are actually the path which is going to be followed by the electrical current. See, if there is a source and consumer which are connected by a suitable electrical connector, so electrical source like battery, generator, etc., and electric consumers like bulb, tube light, fan, all these are electrical consumers and which are connected by a suitable electrical connectors like copper wire, etc. The main in the electric circuits are the driving force is voltage. The voltage, most practical applications of electricity involves the flow of electrical current. See, in the flow of electrical current in a closed path, see, there are two types of electric circuits, open circuit and closed circuit. Open circuit is nothing but if the battery and battery is connected, but if it is not, it is open to the current is not flowing throughout the circuit, something like it is not at all closed. Such circuits are open circuits. See, but in the closed circuits there is a current will flow, see, like in a loop. See, there is no such thing that it is going to break somewhere else. That is so closed circuit. So in the circuits in a closed path, under the influence of the driving voltage, the voltage in the electricity, voltage is important. So voltage is nothing but the amount of work done to carry the charge from one point to another point is called voltage. The unit of voltage is potential difference. The unit of potential difference is voltage. Potential difference is the amount of work done to carry the charge. So here the voltage or potential difference both are on the same. Voltage is the unit of potential difference. Of course, the analogous to the flow of, like just when you compare with the flow of water in the water columns like pressure, low pressure, high pressure, etc. See, water travels from high pressure to low pressure. See, that is water current. Like, see, similarly here higher potential to lower potential, higher voltage to lower voltage, current travels. Just similar to that. So the complete path typically through the conductors this will take place. The conductors are important here. The conductors like copper, silver, so and aluminum, all these are conductors which allows the current very freely through itself. See, in the basically electric circuits, see, the circuit symbols are also important. There are circuit symbols like, if you go to the circuit symbols, different electric circuit symbols, of course it is not given here. See, you take the circuit symbol like resistor, you take the resistor circuit symbol will be, you might have observed, and a capacitor, the capacitor circuit symbol will be like this, and battery, there is a battery circuit symbol. See, this is the battery circuit symbol. More than one cell is connected. One, if it is there, it is called cell. Number of cells are connected in series is battery. And you take other, see, something like there is a tap key and a plug key, etc. These are all circuit symbols you might have observed in the electric circuits, electrical bulb, etc. So we'll come to the, see, in the case of electric circuits, there is voltage. Under the influence of voltage only this will take place. See, the circuit elements, just now we have seen. These are the circuit elements, the electric circuit elements. You take electric circuits are considered made up of some localized circuit elements connected by the wires. See, these negligible resistors, the basic circuit elements, resistors, capacitors, inductors. See, resistor, it is like this. capacitor, see, parallel plate capacitor. This is one plate is positively charged, another plate is negatively charged. Capacitor is also storage device, small storage device, which can store a large amount of charge in a small place. That is capacitor. And you can take it as inductor. Inductor is something like a coil. So the conductor, if it is arranged in the form of some circular coil, or that is called inductor here. So these are the some of the circuit elements, the circuits elements. So in the case of this, and the circuit, the resistors you take. See, resistors are the circuit elements which are basically follows Ohm's law. Resistance is equal to voltage by current, I is equal to V by R. According to the Ohm's law, current passing through the conductor is directly proportional to the applied voltage. And you take I is equal to V by R. And you take the resistors, the resistor combinations, and the difference between conductors and see, basically conductors and insulators, how the current flows through it. You take, there are some mobile electrons, the cross section of a copper wire you take. So there is certain mobile electrons, they travels from, see, there are some free electrons in the conductors. Conductors are like metals, all like aluminum, silver, copper, etc. There are number of free electrons will be more. Those mobile free electrons are, see, the copper valency electrons you take freely throughout the copper metal. Basically you take argon is something, it is completely filled, all like inert gas, etc. There is no free electrons, but in copper there are some free electrons are going to be there. So in the case of free, the copper and other things, see, other conductors, there are some influence, the driving force like electric field if it is applied. So these flow of electricity takes place in the material. So due to the drift of free electrons, there is a current travels from one point to the another point in the circuit. So the major thing is there is some electric field should be applied. That is also, if there is an influence of electric field, there is a mobile charge carriers are moving from one place to another place. See, we will discuss more clearly that. And if it does not allow all these things, like, see, the electrons neighbors, it moves towards them and move away, and creating a chain of interactions propagate through the material with the speed of light. If this is there is external influence, this external influence is only electric field. If this is there, even though there is no charge flow in the material, that is called insulator. Insulator does not allow the charge. Insulator does not allow the charge. That is about the, see, conductors and insulators. Then resistors. The combination of resistors you take. These are the combination of resistors. Resistor combination. If there is a, let us take this is the R1 first resistor, R2 second resistor, and R3. This is one end is connected to the another end. Means the, see, for example, R1 resistor you take. The R1 resistor, the two ends are there. Let us assume that there are two ends are there. This is the first end and this is second end. And this is first end and this is second end for R2 resistor. See, the second end of first resistor is connected to the first end of second resistor. End to end connection. End to end connection. Such end to end connection is called resistors are connected in series. This type of arrangement, what we will call the series arrangement. See, this is R1, R2, R3 are connected in series. In the series arrangement, you have to remember that the resistors connected to end, but second end of the first resistor is connected to the first end of the second resistor, and so on. Like that, if it is connected, that is called resistors are connected in series. So similarly, see, if the resistors are connected in series, the equivalent resistance is equal to the basic thing in the when resistors are connected in the series, the same current flows through all the resistors. The same current flows through all the resistor, and the voltage across each resistor. See, sum of individual voltages. Voltage across each resistor is equal to sum of individual resistors. See, for example, R1 is the resistor having a voltage. V1 is the voltage across R1 resistor. V2 is the voltage across R2 resistor. V3 is the voltage across R3 resistor. So the total voltage is equal to sum of individual voltages. Total voltage is equal to sum of individual voltages in the series connection. So that's why V is equal to V1 plus V2 plus V3 plus, see, something like, and etc. So divided by current, because the same current will be there in the series resistor, that you have to remember. The same current will be there in the series connection. See, that's why current is same. So V equal to V1 plus V2 plus V3 etc. See, now you separate. See, split into cases like V1 by, if let us assume that I1 is the current flowing through the R1 resistor, I2 is the current flowing through R2 resistor, I3 is the current flowing through R3 resistor. See, but the same current, okay, V1 by I1, V2 by I2, V3 by I3, V1 by I1 plus V2 by I2 plus V3 by I3. V1 by I1 is nothing but, according to Ohm's law, see, V by I is nothing but equivalent resistance, that is equal to R1 plus R2 plus R3. So it means R equivalent is equal to, you can understand, R equivalent is equal to R1 plus R2 plus R3. R1 plus R2 plus R3. So this is the main important in the series connection. In the series connection, the effective resistance or equivalent resistance is equal to sum of individual resistors. The sum of individual resistor. It means that R equivalent is equal to R1 plus R2 plus R3. So that is the first important point you have to remember in the series connection. See, coming to the parallel connection. See, this is the second one, this second circuit here, that arrangement of resistors. If you observe carefully in the parallel resistors, see, the resistors here, it is connected. Let us take R1 first end, this is R2 first end, R3 first end, R1 second end, R2 second end, R3 second end. See, first end of all resistors are connected to one common point. Second end of all resistors are connected to another common point. End to one connection, this is called end to one connection. All ends are connected to one common point. Here all ends are connected to one common point. Such arrangement of resistors, what we will call, resistors are connected in parallel. Resistors are connected in parallel. If resistors are connected in parallel, the important points you have to remember. See, here R1, R2, R3 are the resistors. If they are connected in parallel, so the voltage across the resistors is same, okay, in the parallel connection. Voltage across the resistor is same. Potential difference will be same across all the resistors, but the current is divided among the resistors. In previous case, in series connection, current is same, but voltage is different. But in this case, voltage or potential difference will be same, but current is divided among the resistor. It means that current through the R1 resistor is I1, and I2 is the current through the R2 resistor, I3 is the current through R3 resistor. According to the parallel arrangement, the total current is equal to sum of individual currents. Total current is equal to sum of individual current. It means that I equal to I1 plus I2 plus I3. So accordingly you will get the formula. See, if you know I is equal to I1 plus I2 plus I3, you observe here I is equal to, I is the total current in the circuit. The total current is divided into, see, something like I1, I2, I3. So current is divided among the resistor. That point you have to remember. I1 is nothing but, according to Ohm's law, V1 by R1. V1 is the voltage across R1. V2 is the voltage across R2. V3 is the voltage across R3. So V1 by R1 plus V2 by R2 plus V3 by R3. But you can understand here the same potential difference, same voltage across all the resistor. That's why same voltage if it is there, V1 equal to V, V2 equal to V, V3 equal to V. V if you take common, V get cancelled. Then 1 by R equivalent equal to V get cancelled. See, just I will show you here the same step here. V by R1, V by R2 and V by R3. V by R3. So now V by R equivalent equal to V by R equivalent equal to, so you can write here V you take common, 1 by R1 plus 1 by R2 plus 1 by R3. See, V get cancelled. That's what I am telling. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. It means here the reciprocal of effective resistance. The reciprocal of effective resistance is equal to sum of reciprocals of individual resistance. Sum of reciprocals of individual resistances. See, this is the important. So when resistors are connected in series, resistors are connected in parallel. So R equivalent is equal to 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 in the parallel connection. In the parallel connection, this is the formula. In the series connection, okay, the formula is this: R equivalent is equal to R1 plus R2 plus R3. So these resistors combination very important. So the comparison example if you take, there is a resistors are connected in the series connection or in the parallel connection. This is the comparison example. If you take the comparison example, if you take it out first, these two are connected in, see, the R1 and R2 in the first circuit, R1 and R2 are connected in parallel. See, but in this second circuit, R1 and R2 are connected in series. If you observe carefully, in R1, I1 is the current, R2, I2 is the current, and voltage across battery is VB. I is the total current. The total current I is divided into I1 and I2. I1 and I2. So it means I equal to I1 plus I2 in the parallel connection. This is the parallel connection. See, the parallel connection is, so this one is the parallel connection. But this one is the series connection. Here if you observe carefully, R1 and R2 are connected in series. Means negative end of the first resistance connected to positive end of the second resistance and so on. End to end connection. Here voltage across the resistors are different. So here V1, V2 are the different voltages. Total voltage, let us say voltage across battery is VB. According to the series connection, VB is equal to V1 plus V2. See, according to parallel connection, I equal to total current equal to I1 plus I2. So the formulas, if you observe, the formulas in the parallel connection, the 1 by R equivalent is equal to 1 by R plus 1 by R2, 1 by R1 plus 1 by R2. In the series connection, R equivalent is equal to R1 plus R2, R1 plus R2. See, let us take some values, then we'll try to compare the series connection and parallel connection. See, here voltage across battery is, let us assume that there is some voltage. The voltage is 100 volts you take. Some voltage you take. See, R1 value. See, R1 value you take it as some 20 ohms. R1 value is 20 ohms, we will take, or 120, whatever value you can take, 20 ohms. And R2 value you can take it as R2 value, see, 40 ohms. Simple example. The voltage across the battery is 100 volts. Then R1 is 20 ohms and R2 is, see, 40 ohms. If you observe here, see here, the equivalent resistance is 0.95 in the parallel connection. The current is 105 amperes. The current is 105 amperes. The current through the first element, that first resistance in the parallel connection, 5 amperes. Current through the second resistance is 100 amperes. Here, if the same resistors are connected in series, the equivalent resistance is 21 ohms. The equivalent resistance is 21 ohms. See, if you change it here, automatically everything will be changed. So, let us take here R equivalent. See, in the series connection, see, we'll solve one by one. For example, parallel connection, whether this answer is correct or not. First, we'll check parallel connection, then series connection. See, in the first of all, what is the given data? The given data is, see, 100 volts is the battery, and 20-40 ohms are given. See, let us take, we can solve here. See, 100 volts is equal to, here R1 and R2 are connected in parallel. If it is connected in parallel, 1 by R equivalent equal to 1 by 20 plus 1 by 30. See, what we have taken, 1 by 40. 1 by 40. So you take LCM. 20, 40 LCM is 40. 22 ja, 41 ja. 1 by R equivalent. So R equivalent is nothing but 40 by 3. 40 by 3 is nothing but 13.33 amp. See, 13.33 ohms. See, that only the R equivalent value. Just we will check it. See, 13.33. You got the same answer. 13.33. 13.33. Here, the R equivalent in the case of a parallel connection. But see, what is the total current? Total current is nothing but I equal to voltage by R equivalent. Voltage across parallel connection will be same. R equivalent is nothing but, see, voltage across, what is the voltage we have taken? 100 volts. R equivalent, how much you got? 13.33, means that is approximately how much? 13.33 is nothing but, so you can take 40 by, see, 13.33 you got here. So 20 into 40 by 20 plus 40. 20 into 40 is 800 by 60. 800 by 60 is 40 by 3. R equivalent is 40 by 3. So it means it is 300 by 40. 300 upon 40. So if you take that 300 upon 40, see, this is not there. So 300 upon 40. So if you cancel it, 0 0 get cancelled, 4 7 ja 28, 4 5 ja 20. It means total current is 7.5 amperes. You got the same answer, 7.5 amperes in the parallel connection. In the parallel connection, the value is this. Similarly, if you try to find out individual currents, see, if you try to find out the individual currents, what you got the individual currents values? You got the values like individual currents across R1 resistor is 5 ohms, R2 resistor is 2.5 ohms. See, how to find out that? See, according to the parallel connection, the I1 equal to V by R1. V by R1. So voltage is how much? 100. R1 is how much? We have taken 20. So R1 is 20. 25 ja. It means it is 5 amperes. Across the R1 resistor, 5 amperes is the current. You got the same answer here. See, 5 amperes is the I1 value. Similarly, I2 if you find out in parallel connection, I2 is equal to V by R2. So voltage is how much? Voltage is 100 volts. And see, the R2 value is 40. R2 value is 40. 0 0 get cancelled, 4 2 ja. It is 2.5 amperes. See, 2.5 amperes. This is the value you got. So individual currents are 5 and 2.5. Total current is 7.5. Equivalent resistance is 13.33. See, these are the, see, parallel answers. If the resistors are connected in parallel, these are the answers. See, the same question, 100 volts, 20, 100 volts, 20 ohms and 40 ohms. But series connection, what is the answer? Series connection, if you observe, R equivalent is 60 ohms. R equivalent is 60 ohms. How you got this 60 ohms? R equivalent is nothing but, according to series connection, R equivalent formula is what? R equivalent equals equal to, R equivalent is nothing but R1 plus R2. What is R1 value? R1 value is, so R1 we have taken it is 20, R2 is 40, 20 plus 40 it is 60 ohms. You got the answer, same answer. So like that you have to solve. That current in the series connection, total current is equal to V by R. R equivalent. Voltage, total voltage is how much? 100 volts. R equivalent is nothing but 60. So 0 0 get cancelled, 10 by 6. So 2 5 ja 2 3 ja. It means 5 by 3. So 1.66 you will get. 1.66 amperes. You can solve like this. You got 1.66 amperes. Similarly, voltage across first resistance, V1 equal to, see, I1 equal to IR1, it is, I is nothing but 5 by 3 into R1. R1 resistor is how much? 20 ohms. It means that 20 into 5, 100 by 3. 100 by 3 is 33.33 volts. 33.33 volts. Similarly, if you try to find out V2, V2 is nothing but IR2. 5 by 3 into R2 value 40. So 5 4 ja 20, 200 by 3, that is 66.666 volts. See, in series connection, these are the answers. In parallel connection, the previous answers. Just observe the example very clearly, it is giving. See, for one example, you got these values. You can change the values. And you will get different answer. For example, instead of 100 volts, you take, see, some other value. You take some other value like 500 volts you take, or 600 or 450 volts. You take 450 volts. And resistance also you can take different value like, see, 35 or any value you can take, 35, little difficult calculation. Here R2 value you can take, R2 value it is 55 you take, R2 value. So even though answers will come, see, you got the answers. Parallel connection answer is 21.388. So R equivalent is this, current is 21. See, total current is this, individual currents 12.85, I1 is 12.85, I2 is 8.18. For these are the answers for parallel connection. These are the answers for series connection. Series connection R equivalent is 90 and total current is 5 amperes. Voltage across first resistance is 175 volts. Voltage across second resistance is 275 volts. So thank you very much. Thanks for watching this video.